Welcome to the Tech Egg. Don't get scrambled. Enjoy the video.
You start by making the GPU visible and compatible. First, run NVIDIA CUDA to confirm driver and GPU model so you know what CUDA version to target. Then create a Conda environment and install the CUDA-enabled build of your framework. Pick the version that matches your driver to avoid runtime errors. Once done, install Jupyter Lab or Notebook and ipykernel and register the environment as a kernel. This gets you from system-level readiness straight into a notebook kernel that can access the GPU. Once the kernel is active, select it in Jupyter and verify the kernel name matches your GPU-enabled env. In a cell, run framework checks, for example, Torch. CUDA is available, or TensorFlow's list physical devices to confirm access. Next, explicitly send data and models to the GPU with to device or by using the device context manager and set dtypes deliberately to control memory. If you use data loader, enable pin memory and adjust batch size. These steps let you actually execute computations on the GPU instead of the CPU. Finally, run a quick training or inference cell while watching NVIDIA CUDA to confirm GPU utilization and memory use. If memory fills, reduce batch size, enable mixed precision, or use gradient accumulation to maintain throughput. Save checkpoints by moving models to CPU before serialization to avoid device errors. If something goes wrong, restart the kernel and check for driver versus CUDA toolkit mismatches. Make sure the installed framework build targets your CUDA version. That single troubleshooting step usually resolves most access problems.
Thanks for watching. Consider subscribing if I helped unscramble your problems.